NASA's incredibly powerful James Webb Space Telescope has been in space for 3 days now, but perhaps the riskiest part of its journey to deep space is just getting underway. Soon, the telescope will initiate an intricately choreographed mechanical dance as it slowly contorts its shape and unfurls in order to reach its final form for observing the distant cosmos. It's a type of reverse space origami that's never been performed before, but it's absolutely necessary for the James Webb Space Telescope, or JWST, to fulfill its mission. The telescope was simply too massive to launch on any operational rocket while fully extended. So when it catapulted into space on top of a European Ariane 5 rocket on Christmas Day, it made the nail-biting trip folded in on itself like the world's most expensive Swiss Army knife. We sometimes call Webb the Transformer Telescope. Now over the course of the next 2 weeks, JWST will twist and reshape, deploying one beam here, a mirror there, until it is completely configured for peering into the deepest parts of the universe. We sometimes call Webb the Transformer Telescope. Amy Lowe, the JWST alignments engineer at the telescope's primary contractor Northrop Grumman, tells The Verge, "It's a daunting process with hundreds of moving parts that engineers have tested over and over again on the ground, as it has to be nothing short of flawless. But there are many points along the way where the failure of one small release mechanism or pulley could jeopardize the future of the entire JWST mission. While mission controllers on the ground have a few troubleshooting techniques they can employ if something gets stuck, ultimately the JWST spacecraft must do every deployment on its own to near perfection." JWST is heading to a final destination roughly 1 million miles from Earth, and there are no operational rockets or spaceships that can safely bring astronauts to such a distance to give the telescope a tune-up. And even if humans could reach it, JWST just isn't designed to be serviceable. So if the telescope breaks in a fundamental way, that's it for a mission that is running NASA a total of $9.7 billion. It may all sound like needless complexity for a mission of this magnitude, but there never was an easy path for JWST, according to NASA. I actually strongly believe it's not possible to make it simpler within the constraints that we have. Thomas Zurbuchen, the Associate Administrator for the Science Mission Directorate at NASA, tells The Verge, "This is what it is. Designers of JWST knew from the beginning that their creation would have to unfold while in space. In 1996, when scientists first proposed making a telescope like this, NASA's administrator at the time, Dan Goldin, challenged engineers to create the spacecraft with a primary mirror that was up to 8 meters wide. Ultimately, designers settled on a mirror that was 6.5 meters, or 21 feet across, but that decree determined JWST's folded fate. That's because the largest rockets currently flying aren't wide enough to carry a mirror of that size. Whenever you launch something into space, the spacecraft has to fit inside a rocket's payload fairing, the bulbous structure that sits on top of the rocket throughout the first part of flight. The fairing is critical, as it shrouds the spacecraft during launch, protecting the payload from the atmosphere until reaching space. However, the fairing's width is a major limiting factor for a spacecraft's design, since the vehicle must fit inside. It's a problem that those in the space industry often refer to as the tyranny of the Ariane 5 rocket has one of the widest payload fairings currently on the market, spanning 5.4 meters, or nearly 18 feet wide. But that's still too small to house a mirror fully extended. So from the start, JWST mission designers built the mirror in segments with 2 flaps on either side that could swivel inward or outward. It was a major design challenge, as the segments need to come together to behave like a single, flat mirror in order to gather light from the distant cosmos. Unfurling a primary mirror has never been done before on orbit in space, says Lowe. Unfurling a primary mirror has never been done before on orbit. JWST will deploy its mirror flaps around 12 to 13 days after launch. But before that happens, the observatory has an even more complex deployment that it must get through, one that will take up to 6 days to complete. It's the deployment of JWST's Sun Shield, an intricate apparatus designed to block heat from the sun and keep the telescope extra cool while in space. While the deployment process is designed to be flexible and things could change, the first step of the Sun Shield deployment is supposed to get started today, which means almost everyone associated with this mission will be holding their breath for the next week. The Sun Shield itself is, of all of our deployments, that's the one that is the most complex. Lee Feinberg, the optical telescope element manager for JWST at the NASA Goddard Space Flight Center, tells The Verge, "It has the most moving parts. The Sun Shield is a necessary feature because of how the JWST is designed. The telescope will be observing distant stars and galaxies in infrared, a type of light that is invisible to our eyes but is emitted by anything that holds heat. But in order to collect infrared photons, JWST must operate at an unbelievably cold temperature, as low as -370 degrees Fahrenheit. If it gets too warm, the telescope might emit too much of its own infrared light, which could interfere with the spacecraft's observations of the universe. Enter the Sun Shield, which provides some impressive sunblock for JWST. The shield consists of 5 ultra-thin layers of a shiny material called Kapton. Each layer the size of a tennis court. The outermost layer will always face the sun and get most of its heat, operating at a scorching 230 degrees Fahrenheit. But each successive layer will be cooler and cooler, so that JWST's instruments stay nice and cryogenic. The shield's heat-reflecting membranes are so delicate that extra special care and engineering were needed in order to extend the layers outward in space and pull them taut without ripping. There are systems that will spread the layers out and tension them, Feinberg says. It's a little bit like a sail on a boat in terms of how you kind of wind it up. There are moments when there really are no backup options. The entire process relies on hundreds of different moving parts, including up to 140 release mechanisms, 400 pulleys, 70 hinge assemblies, and 90 cables. According to NASA, there are also various contingency plans in place in case a deployment doesn't perform as expected. NASA has the option to resend commands to the telescope in case the first command does not trigger a move. Engineers have also built as many redundancies into the spacecraft as they could. There are areas with multiple circuits that can perform the same task in case the primary circuit doesn't fire properly. But there are moments when there really are no backup options. Throughout the deployment process, there are more than 300 events known as single-point failures. Those are the deployments that have to work as designed because they can't be built with redundancy. Single-point failures are funny little things. They're used a lot, says Lowe. And technically what they mean is this thing must happen. JWST relies on them heavily throughout the deployment process. For instance, a total of 107 release devices are needed to release the Sun Shield membranes, allowing them to unfurl to their full shape. All 107 of those devices are single-point failures, according to Lowe. NASA is no stranger to single-point failures, though. When the space agency landed its Perseverance rover on Mars this February, the landing sequence had roughly 100 single-point failures baked in, according to Zurbuchen. The entire landing went flawlessly. Additionally, NASA and Northrop Grumman have tested JUICE's various deployments on the ground for the past 2 to 3 years, intricately rehearsing them for the final show. Each component was tested individually on the ground dozens of times first before being added to the spacecraft. And then the entire telescope was folded and unfolded multiple times as a cohesive unit. So do we have confidence that we will deploy on orbit? Yes, we do, says Lowe. And the reason is because we go through such rigorous testing from basically the ground level up. Do we have confidence that we will deploy on orbit? Yes, we do. JWST's testing took many years longer on the ground than planned, but it had to be rigorous because of its inability to be repaired. It's one of the biggest differences between JWST and its predecessor, the Hubble Space Telescope, which has been orbiting the Earth since 1990. Hubble was purposefully designed to get tune-ups while in orbit by visiting astronauts. JWST doesn't have that capability. Plus, sending humans to the telescope would introduce too much heat anyway. Even if you put a spacesuit around you or me, it's still way warmer than the telescope environment, says Zurbuchen. Though a human servicing mission is not feasible for JWST, NASA did make one small design tweak in case the agency wants to give the telescope a tune-up someday. Included on the back of JWST are stickers in the shapes of crosses. They're meant to serve as targets to help guide a potential robotic spacecraft visitor to JWST in the future. Over the last decade, various space companies have been working on servicing satellites designed to catch up with satellites already in space and grab hold of them, either to refuel their tanks or to tweak aging components. It's possible that one day, NASA may want to send a servicing satellite to JWST to add more propellant to the telescope's tanks, extending its time in space. If that happens, the targets will provide a reference point for where the visiting spacecraft should attach to fill up JWST's tank. However, no one at NASA is even thinking about such a refueling mission right now. Everyone associated with JWST is squarely focused on the deployments. And once the telescope is completely unfurled over the next 2 weeks, there is still plenty of work to be done as the observatory travels through deep space. NASA will continue to adjust JWST's mirrors ever so slightly, ensuring that they all align as intended. And then about 29 days after launch, the telescope will execute one final burn of its thrusters, putting it into its final position in deep space. At that point, the work is only beginning. Mission personnel will then test out and calibrate all of JWST's instruments to make sure they work properly. That process will take months, with science operations scheduled to begin sometime this summer. So even if JWST does deploy as intended after 2 weeks, the anxiety doesn't really end. That's when I think a lot of us will breathe a sigh of relief, but of course, the instruments in the mirror phasing would have just begun, Lowe says. A different group of folks, the instrument builders, designers, engineers, and the scientists, would only just start to be holding their breath.